Hi guys, welcome to today's class. We're going to start off right now. Okay, this is the first time that I'm going to explain an example like this. And what we have to do is we're going to graph this rational function, but we're going to have something a little bit different. But first of all, for starters, guys, the first thing that you have to do is identify if it is the first, second case. We have worked just with the first and second case. Can someone tell me? Okay, I just wrote it down. But why this is the second case?
Because the degree of the denominator is greater than the one of the numerator.
That's it. Okay, you have to look at the highest degree in the top and bottom, and you see that the bottom is the greatest one. Square, and this is linear term. Okay, that is the case one. Okay, keep in mind this is case one. But someone also told me, Mister, that function can be factored. We can simplify something. Okay, keep that in mind. Okay, f of x equals 2. Okay, x minus 1, I'm going to copy this. I can not factor that anymore. But this denominator, guys, can be factored by using the
big X method.
big X method. But in order to avoid any mistake, guys, we're going to do the big X method, right? We can make a mistake. Okay, a times c and b. Okay, a times c, guys, is 1 times 3. That's going to be 3.
And 94.
94, thank you. Two numbers that you can factor 3. It's a prime number. Okay, that is
3 times 1.
3 times 1, 1 and 3 is the same. Okay, the sign, guys,
Both negative.
and most of it negative. Okay, negative 1 and negative 3 is negative 4. And negative makes this positive. Everything is working out. Okay, that's it. Okay, guys, this is how I'm going to factor that out. Okay, let me copy that. X minus 1 and x minus 3. Okay, that 3 is not seeable. Okay, this is what we got, guys. Okay, keep in mind, guys, what is a vertical asymptote, guys? How do I find a vertical asymptote? The vertical by setting
denominator.
by setting the denominator equals 0, right? I have 2 equals 0. Keep that in mind because I need to point something out. Okay, but let's try to simplify it if we can. Okay, if we can simplify, let's do it. Okay, what are we gonna get? X minus 1 over x minus 1, guys.
1.
Okay.
Cancel.
We can cancel this out. And we're going to get 1 in the numerator over
x minus 3.
X minus 3. Okay. This piece of function is going to help me. Okay, this is what we got. Keep in mind that we cancel, guys. We got this as a vertical asymptote, but we have to know what's going to happen with that. Okay, guys, with this information, we're ready to identify vertical and horizontal asymptote. Okay, we already know this is the first case, right? Okay, let's try to find the asymptote. Okay, let's start off with the horizontal asymptote. What is the horizontal asymptote, guys? For the first case, right?
Y equals 0.
Y equals 0.
The number that is here, right? Plus something. Okay, let's see the original expression too. Okay, we got nothing here. Okay, that is 0. Y equals 0. Excellent. In the second case, do you remember we divide the coefficient of the little coefficient on the top and in the bottom too. Okay, y equals 0 in this case. Okay, that's it. Okay, this is my vertical asymptote. Horizontal asymptote. Sorry. Now we need to find out the vertical asymptote. Okay. Keep in mind, guys, in my original expression, when we factor this, okay, because we have to set this equals to 0, we got this, right? This equals 0. Okay, the two of them. Okay, let's see it. The two of them. That is x minus 1. Let me see this one. X minus 1 equals 0. And the other
x minus 3 equals 0.
X minus 3 equals 0. Okay, we got two of them. Okay, let's solve it. X equals positive 1, right? But take a look at that. At the end, this negative 1 disappears, right? Because we cancel it. This, guys, is not going to be it's not going to be a vertical asymptote. It's going to be a whole. Okay, Mister, what is that? Okay, I'm going to explain you when I graph that. And the other one, guys, this one, x minus 3 is just solve it. Okay, normally, x equals
3.
X equals 3. Okay, this is actually my.
That is the vertical asymptote.
That is my vertical asymptote. Okay, this is just going to be a whole. Okay, that's it, guys. With this information, let's represent in our coordinate system, guys. this asymptote. Okay. Horizontal asymptote is y equals 0. Okay, y equals 0, guys, is something pretty simple, right? Okay, let's plot it in the x-axis. Okay, I'm gonna plot this here. This is my y equals 0. Okay, what else? And the vertical asymptote, we only have one. Okay, x equals to
X equals positive 3.
positive 3. Okay, not in the negative side. Okay, positive 3, x is this, exactly this line. Okay, this is not a straight line, but x equals to positive 3. Okay, this is all my asymptote, guys. What is next? We're gonna take some values to the right and left, and let's see how the graph behavior is going to be. Okay, let's take which values is x equals 3, right? That's the middle of the table. Let's copy the last function. We can use the original function, but I'm gonna use the last function. That is 1 over
1 over x plus 3.
1
Minus 3.
minus 3. Okay, minus 3. Okay, no problem. This is the first mistake that we made in this class. Okay, let's take values, guys, to the left and right of the vertical asymptote. To the left, 2 and 1, right?
Yes, 2 and 1.
Okay, 2. Okay, but we can take 0, guys. I like taking 0. We can take 2 to the right. Take a look. To the right, 2. And we can take 0, right? Because 0, guys, is simpler. But you can take 1. It's going to be the same. And for values greater than the vertical asymptote, this is 3. We can take 4 and
5.
4 and 5. Okay, perfect. 4, that's going to work for me. 4 and 5. Okay, let's zoom in, guys, and let's try to simplify this. We have 6 minutes to do that. Okay, 1 over parentheses minus 3. Okay, the value for this is going to be
0.
0. Okay, what is that, guys? 0 here. We only have 1 over minus 3. What is that, guys? This is 0. 1 over minus 3.
Negative 0.3.
Yes, 0.3. 33. Excellent. The next, okay, 1 over this minus 3. Let's see, guys. The value for x in this case is going to be 2.
2.
Okay, we get this, right? 1 over 2 minus 3 is minus 1, right?
Negative 1.
Negative.
1.
Thank you.
1.
1. Excellent. And with 4, let's do it with 4. 1 over parentheses minus 3. Okay, what do we get out of this, guys? 4. If it is 4,
1.
1.
1.
1 over 1.
1 over
1.
positive 1. Excellent. And with 5, what's going to happen with 5? Okay, we're going to get 1 over 5 minus 2.
0.5.
0.5. 0.5.
Take a look, guys. This is the same, right? Okay, we only have to take something into account. Okay, this is what we got. Okay, let's plot the points, guys. 0 with negative 0.3. Okay, 0 with negative 0.3. Okay, negative 0.3 is going to be a little bit down, a little bit, just not that much. Okay, okay, I'm going to try to make a point here. Okay, no, that point is not. Okay, let's say that is the point. And the other one, 2 for x. Okay, 2 for x. Negative 1. Okay, 1 unit down. Okay, thank you. 1 unit down. And we already know how the behavior is going to be, right? And let's go to the right side. 4 for x. Okay, 4 for x. And 1 for 1 unit up. Okay, thank you. Okay, that's it. And 5 for x. How many for y?
0.5.
The half. Up. Okay, something like this. Okay, guys, that is the 2 points. Okay, now we can easily graph that. Okay, I'm gonna make a, keep in mind this is a horizontal asymptote. The graph is going to be approaching and getting closer to that line, but it's never quite touching it. Okay, let's try to make a line. I'm gonna try to make a line like this, something like this. Let me see if I'm doing it great. Okay. Sorry that I almost touched it. But it's my I'm just using my finger. Okay, sorry for doing that. Okay, now. Oh, this was better.
That's better.
Learning how to do this, guys. Okay, this is how we do the graph, guys. Okay, but we have to take into account this, right? Do you remember that we canceled this expression, guys? X minus 1. We cancel it because we have the same denominator that was canceled out. This value, guys, you need to solve it for x2. Okay, you need to solve it for x, but this value is going to be a whole in your graph. What is that? X equals to 1. Okay, let's look for x equals to 1, guys. X0, x1, right? Okay, exactly in this point, in x equals to 1, guys, this graph is going to have a hole. Okay, let's make it that. Okay, I'm going to erase that. Okay. In 1, this is x equals 1, right? Okay, this one, take a look. Let me see, x1 here. Okay, I'm going to erase that and I'm going to make a hole. Okay, I'm actually making a point. Okay, let me erase that a little bit. Okay, I'm going to erase that. Okay, I can't. Okay, here, and I'm going to make a circle, okay, an empty circle, okay. Okay, that. Okay, that is what we have to do, guys, because this point in the real expression, the function is not defined. But since that we cancel, this is going to be a hole, just like that. Okay, keep that in mind. We're going to have more examples to practice this kind of function with holes in the next class, of course.